Okay, so in the first video we talked about the mole ratio and how important it is when we're doing calculations to go from one substance to another substance when we're trying to actually figure out amounts. And that uses a balanced chemical equation. Now, to take this one step further, there are three basic types of stoichiometry problems that we can basically work with. And the first one I'm going to talk about is a gram to mole problem. This is a problem where we start with grams of a substance, we have a balanced chemical equation, and we try to find moles of another substance. So, what are we starting with? We're starting with 15.86 moles of ammonia. And what are we trying to find? Since this is from grams to moles, you would expect it to be moles. So in this case, it's moles of hydrogen. So we're trying to get over here to moles of hydrogen. Now, this kind of problem has two steps. And actually, you know how to do the first thing. You've done this back in the moles unit. The first thing, pretty much always in most chemical, quantitative chemical problems, is you got to convert something to moles. So we're starting with grams. We know that the relationship between the coefficients has to do with the number of molecules or the number of moles. Let's get this to moles, use our mole ratio to then determine, once we know the moles that we start with, how many moles of the other substance are actually required to make it. So, if we're going to do this, we're going to first convert this to moles. Now, how do we do that? Well, basically what we're going to do is if we're starting with moles and we want to, grams, should be grams here. We're starting with grams and we're trying to go to moles, we need to divide by the molar mass. So for every 1 mole of ammonia, and I'm going to have to try to do this in my head. Let's see, 14.01, 3.24, so it would be 17.03. So 17.03 grams of ammonia. That should be right. And so what that's going to do is it's going to convert our grams of ammonia. It's going to convert it to moles of ammonia. And now when we got to get to an end product of moles, and we've got moles, we got to use the mole ratio step. Remember, in all of our equations, the mole ratio step is relating numbers of things to each other, which have to do with the proportions that come from the coefficients of the balanced equation. Whatever you're going to goes on top. So we're trying to find hydrogen. So the coefficient of hydrogen goes on top. And whatever we're coming from, which is ammonia, its coefficient goes in the bottom. Okay. Now, to finish it, we just got to do some calculating. So I'm going to take 15.86. I'm going to divide it by 17.03, hit enter. I'm going to multiply it by 1.5 because 3 halves is 1.5. So times 1.5. Now, I'm getting 1.3969 blah, blah, blah. How many sig figs do we have? This has 4, this has 4. Remember, coefficients are exact counts, so we do not use coefficients in our determination of significant figures. So it's going to be 1.397 moles. .397 moles of hydrogen is produced in this reaction when we start with, or is needed in this reaction when we have produced 15.86 grams of ammonia. We needed 1.397 moles of hydrogen.